Next is, since a radius bisects a chord at right angle, there is often an opportunity to use a Pythagoras theorem, right? So here, 90 degrees a right angle is generated, where in the triangles a right angle is generated, we can use the Pythagoras theorem also. Okay. Here is another example. The diagram shows a radius OT that bisects the chord AB at M. MB is equals to 12 centimeters. So it means that this is 12, this is also 12. Okay. The radius of the circle is 13. It means that the total length is 13. So we can say that this length must also be 13 because this is also a radius. Okay. So now we have to find mt, this length. So first of all, we have to find this length by using this triangle where the base is 12, the hypotenuse is 13. We can find the altitude. Altitude square is equals to hypotenuse square minus base square, that is 13 square minus 12 square. So it will becomes 169 minus 144. So what is the answer? OM square is equals to 25. So it means that OM side is 5 centimeter. So this side is 5 centimeter. And you have seen that in the question the total radius is given as 13. So it means that OT is basically equals to 13. We have to find the value of MT. So MT will becomes the total minus the OM, that is 5. So MT will be 8 centimeters. So this is your answer. Any problem in this example? Next is the exercise 17.1. Also in this exercise we just use these previous theorems which we have studied, right? And you have to do some questions from this exercise. Question number 1, question number 3, question number 5 and question number 7. All these questions, do these questions and send it to me on WhatsApp group, right? And the next one is the next topic, that is 17.2, angle properties inside a circle. Now we deal with the angles property inside the circle. There are several important theorems about angles inside a circle. You will need to learn these and use them to solve numerical problems. You may also be asked to prove why they are true. So we use the angle problems, angle theorems, as well as their proofs. Now consider 2 points A and B. So we consider 2 points on the circumference of the circle A and B, and the angle subtended by the arc AB, this one angle at the center is equals to AOB, right? Okay, that's obvious, that's fact. Next is the angle subtended by the arc AB. Now this is the arc and the angle subtended by the arc on the point X, that is on the circumference. Here the point O is the center, but in this the point is on the circumference of the circle. So there is a theorem in circle geometry which just relates these two angles, the angle on the center of the circle by the same arc and the angle on the circumference by the same arc, are related by that theorem. That there is a theorem is in circle geometry which states that angle AOB is exactly twice the angle AXB. So it means that this will becomes 2x if this will be x, right? So angle on this center of the circle is twice to the angle of the circumference. Now we can write on a single, we can draw on a single diagram. As let's suppose this is 2x, so it will be x. The angle at the center will be 2x, the angle at the circumference will be x, that is exactly the half of the angle at the center. Okay, this result is quite easy to prove and is the basic theorem upon which several other circle theorems are built. So here is the theorem statement of uh, this simple method. So angle subtended by the arc at the center of the circle is twice the angle subtended by the same arc at circumference of the circle. We can also refine the statement as the angle subtended by an arc at the circumference of the circle is exactly the half of the angle subtended by the same arc at the center of the circle, right? So now we have to find the proof. Make a diagram to show that the arc AB, the center O and the point X on circumference of a circle. So we just uh, make a diagram in which a chord AB, arc AB, for angle AOB and angle AXB, right? After that we can just meet this x by O. From x draw a radius to O and produce it, which means extend it slightly, and we just slightly extend it. Okay, after that the triangle AOX is isosceles triangle. How? AOX is isosceles triangle because this side and this side are radius, so these two sides are same, right? OA and OX are radii of the same circle, therefore angle OAX and OXA are equal. These are marked on the diagram with a letter A, right? Again, this angle is letter A, this angle is also letter A. So now we deal with this triangle BOX. In this triangle you can also say that this is an isosceles triangle. Why? Because here is also a radius and also a radius, so this angle and this angle are also same. We name these angles as B, right? After that you can say that the angle AXB is equals to A plus B, right? Okay, now this one is AXB. After that, if you can see in this diagram, if these two angles are A and A, what is that angle? That angle will be 180 minus 2A, right? Again, that angle will be 180 minus 2B. Any problem? Okay, so we write it as 180 minus 2A, 180 minus 2B. So the sum of all angles, let's suppose this is a point, and the sum of all angles at a single point are added to 360. It means that 180 plus 2, sorry, 180 minus 2A plus 180 minus 2B, and the third angle, I suppose that this is x plus x is equals to 360. Okay, so this 180 goes on other side and subtracted by 360, it will becomes x is equals to 360 minus 360 plus 2A plus 2B. So here x will be 2 times A plus B, right? As you can see that, so this angle x will be 2 times a plus b, that is twice